Hello again. Today we are talking about significant figures. So there are two types of numbers, exact and inexact. Exact numbers are attained by counting or by definition. For example, a dozen of eggs is 12 eggs, or 100 cents in a dollar. All measured numbers are inexact. So, rules of significant figures. You will need to type out all of these rules or everything that is underlined in this slide. So, if you want to pause and then go ahead and type it out and then listen while I go over it, or listen and then type it out later, whatever works best for you. So, the first rule, non-zero digits are always significant. So, if we look at 38.57, there are four numbers there in that number, and none of them are zero, so they're always going to be significant. So there's four significant figures, or sig figs, in 38.57. The next example there is 283. None of those are zero, so they're all significant. So you would have three sig figs. Now, when we start seeing zeros, things get a little tricky. So we're going to go through the different rules that explain what zeros are significant and what zeros are not significant. So rule 2, zeros at the beginning are never significant. So you see here, you have some zeros in the very front. There's no numbers that's not a zero in front of it, so they are not significant. So the only two numbers are the 5 and the 2 that would be significant. So for 0.052, there are only two sig figs. Rule 3, zeros in between are always significant. So in 6.08, this zero is in between two other numbers, which means it is significant. So 6.08 will have three sig figs. Rule 4, zeros at the end after the decimal, always significant. If there is a decimal there and there's zeros at the end, then they will be significant. So 39.0. You see that decimal, and there's a 0 at the end. There's also a 3 and a 9, so there would be three significant figures. Rule 5, zeros at the end with no decimal may or may not be significant. For today, we are going to say that they are not significant. So, for example, 23,400. There is not a decimal. So, the only thing that would be significant is the 2, the 3, and the 4. So, there are three significant figures. Scientific notation eliminates uncertainty. So if it's in scientific notation, everything in the base is significant. So for example, this would have 1, 2, 3, 4, 5 significant figures. This one has 1, 2, 3, 4 significant figures. This one has 3 significant figures. So if it's in scientific notation, you don't even have to worry about those rules we just went over. It is automatically significant. So significant figures and decimal places are not the same thing. I know some people get that mixed up. So 38.57 has 4 significant figures, but only 2 decimal places after the decimal. So since all of these are not zero, there'll be 1, 2, 3, 4 significant figures. So I'm going to do some examples for you guys on the whiteboard so you can see me kind of work through it and hopefully answer any questions you have. All right, so here's some practice for significant figures. So the rules, to remember the rules, if it's not a 0, it is significant. If a 0 is in between non-zeros, it is significant. If it is in the beginning, not significant. If it is at the end with a decimal, it is significant. And if it is at the end without a decimal, it is not significant. All right, so number 1 over here, I have 77. Well, 7 is not a 0, so they would both be significant. So you have 1, 2 significant figures. So your answer for that would be 2 sig fig. The next one we have 8002. So 8 is not a 0, so it is significant. These zeros are in between a 2 and an 8. And right here, a 0 in between non-zeros are significant. So you will need to count those as significant. And of course, 2 is also significant. So for 8002, you would have 4 sig figs. Okay, this one, you have 0.010. These two zeros are at the beginning. So over here, if it is in the beginning, it's not significant. So those are not sig figs. This one is because it's not a 0. Now here we have a 0 at the end, but there's a decimal. So if it's at the end and there's a decimal, it is significant. So this would have 2 sig figs. Okay, 800. The 8 would be significant because it's not a 0. Now these two zeros are at the end, but there's no decimal. If it's at the end without a decimal, it's not significant. So this would just have 1 sig fig. 800.0. So we know 8 is significant, but now we have a decimal. Zeros at the end with the decimal are significant, which means all of these zeros would be significant. So we have 4 sig figs. And then the last example. Here we have a 0 in the beginning. Well, here, if it's in the beginning, not significant. So we don't care about that 0. The 2 is significant. The 2 is significant. This 0 is in between a 2 and a 5. Since it's in between, it is significant. And the 5 is also significant. So here we have 4 sig figs. Okay, if you need some more examples or if you are confused about these rules, please let me know, because the sooner you get these rules figured out, the quicker you'll be able to do this work and get it done and understand it, and hopefully be able to answer your questions on the next slide.